In this video, we're going to discuss a special counting technique that is used when you want to arrange a bunch of objects where there's groups involved, so some of the objects want to stay together in some way. So we'll start with an example. So suppose 4 couples go to see the band Belle and Sebastian in concert. How many different ways can they sit in a row of 8 chairs if you want each couple to sit side by side? So let's think about what this would look like. Okay, so I have my 4 couples. I'm going to call them A1 and B1, A2, B2, A3, B3, A4, B4. So this is couple 1, 2, 3, and 4. So we want them to be stuck together. So what we're going to do is imagine gluing the couples together, or linking their arms, maybe you could think of, seeing as how they're people, so that they move as a unit. So instead of 8 people, we want to arrange 4 couples. Okay, so we only have 4 objects at the moment because they have 4 groups of 2 things. So we're going to arrange the 4 couples. So because there's 4 objects, the couples, and we want to arrange all of them where the order matters, there is 4 factorial, or if you want 4 permute 4, which is 24 ways to arrange the couples. Okay, so if you have 4 things and you want to arrange all of them, the number of ways to do that is 4 factorial. But we can also arrange within each couple. Okay, so if the couple stands, let's say couple 1, if they stand A1, B1 is a different arrangement than B1, A1. So we want to arrange within each couple. So for each couple, there are 2 factorial, or 2 ways to arrange the people in the couple. So the total number of seatings at the concert is going to be, so we're going to first arrange couples, and then we're going to arrange within each couple. So we've already counted each of these steps. So there's 4 factorial ways to arrange the couples, and then 2 factorial ways to arrange each of the 4 couples. And we have to do each of these things in order for the couples to know where to sit down. So we want to multiply. We're using the multiplication principle. So what this ends up being is 4 factorial times 2, or 2 factorial to the power 4, which is 384 ways. So let's think about what we actually did when we were using this technique. So what does the technique look like? So we want to keep things together. So what you want to do is think about gluing the objects to be kept together, and treat them as one object. Treat as a single object. So in our example above, we did that with a few different, we had a few different objects that needed to be glued. So for each one, we treated them as a single object. Okay, then what we want to do is arrange the remaining objects together with the glued object. Okay, now it could be multiple, so objects. And then you could sometimes combine these steps, but I like to, I like to do them separately. And then we want to arrange within each of the groups, if necessary. Each of the glued objects. Okay, now I'm going to write if necessary. So not all the time is this step necessary to do. So you want to be careful and think, does the order within this group matter? Okay, so that's the basic idea for this technique. Now let's try it out in a couple more examples. So consider the letters in the phrase "I like math," ignoring the spaces. How many linear arrangements use all the letters and have the I's next to each other? So we want the I's to be together. So what I'm going to do is glue them together. And the way that I'm going to illustrate that is I'm going to put them together in a box. Okay, so this is just one object. And then I have all the other letters separate. So I have an L, a K, an E, an M, an A, a T, and an H. So how many objects do I have in total? So I have a box, and then I have 1, 2, 3, 4, 5, 6, 7 letters. Okay, so we have 7 letters plus a box of letters. So we have 8 objects in total. So the first thing we want to do is arrange these objects. So because we want to arrange all of them, there's going to be 8 factorial, or 8 permute 8 ways to do this, and that is 40,320 ways to arrange those objects. Now we want to think, do we need to arrange within the box? So here, we don't actually need to do this arranging, since the letters in the box, are both I's. So it looks the same no matter the order they're written. So you don't need to arrange it because they're the same letter. Okay, they're not distinct. So then the total is just 8 factorial. So there's 8 factorial, or 40,320 linear arrangements. So I'm going to write arrangements with the I's together. Okay, so stuck together. Okay, let's try another one. So here we have 8 people going to an engagement party, and Stacy, Carol, and Tanya are part of the 8. Okay, and how many ways can the people arrive at the party if you know Stacy, Carol, and Tanya all arrive at the same time, and everyone else arrives at a different time? Okay, so again, we want to group Stacy, Carol, and Tanya. So I'm just going to use their letters. So they're one object because they're all coming at the same time. Now everyone else is coming at a different time. So there's 3 people in this box. So there's going to be 5 other people to make 8 in total. Whoops. And they're all coming separately. Okay, so we have one object, and then we have 5 other things. Okay, so that means that we have 6 objects total. So there are 6 factorial, which is 720 ways to arrange the 6 objects. So I'm calling them objects because 5 of them are people, and one of them is a box of 3 people. Okay, so it's slightly different. So there are 720 ways to arrange the 6 objects. Now again, do we need to arrange Stacy, Carol, and Tanya? Well, they're all coming together, so the order they sort of enter the house doesn't really matter. Sort of imagine them walking through a giant door where they all come in at once. So we again do not need to arrange within the box, since they all arrive at the same time. So there's no order among them. So the total is just 6 factorial. So 720 ways that people could arrive, assuming that Stacy, Carol, and Tanya all come at the same time. Now, if they were sitting down, then the order within this would matter. So they'd have 3 seats all together, and we want to know who sat in which seat. But because here they're just coming to the party, there's the order, they're all coming at the same time, so there's no order involved. So that's a few examples of arranging with groups involved.